So let's solve one more question. Find the value of, and this question has got two parts, and the first part is find the value of sine of cot inverse 4 upon 3. And the second part is sine of secant inverse 17 upon 8. So first we shall solve the first part. Now here we have to find out the value of sine of cot inverse 4 upon 3. So first we shall write cot inverse 4 upon 3 in the sine inverse form. And now cot inverse 4 upon 3 means this is an angle in a right angle triangle in which the ratio of base to the perpendicular is 4 upon 3. So let's draw a right angle triangle, and here is the angle theta, and the side just opposite to the theta is perpendicular and the other side is 4. So now here if the base is 4 unit, then the perpendicular is 3 unit. And now what will be the value of hypotenuse? Now as per the Pythagoras theorem, the hypotenuse is equal to the square root of the sum of squares of perpendicular and the base. So that means here hypotenuse is equal to the square root of 4 square plus 3 square, which is equal to the square root of 16 plus 9, or the square root of 25, which is equal to 5. That means the hypotenuse in this right angle triangle is equal to 5 units. And now in this right angle triangle, what will be the value of sine theta? And sine theta is equal to perpendicular upon hypotenuse. So sine theta is equal to 3 upon 5. And here theta is equal to sine inverse 3 upon 5. But theta is also equal to cot inverse 4 upon 3. So that means cot inverse 4 upon 3 is equal to sine inverse 3 upon 5. So in the expression sine of cot inverse 4 upon 3, we can write sine inverse 3 upon 5 in place of cot inverse 4 upon 3. So now this expression becomes sine of sine inverse 3 upon 5. And remember, sine of sine inverse x is equal to x, where x lies in the interval -1 to 1, and here x is 3 upon 5, which is greater than or equal to -1 and is less than or equal to 1. So that means sine of sine inverse 3 upon 5 is equal to 3 upon 5, or the value of sine of cot inverse 4 upon 3 is equal to 3 upon 5. And now let's solve the second part, in which we have to find the value of sine of sec inverse 17 upon 8. First we shall convert sec inverse 17 upon 8 into some form of sine inverse x. Now sec inverse 17 upon 8 means it is an angle in some right angle triangle in which the ratio of hypotenuse to the base is equal to 17 upon 8. So for that, let's first draw a right angle triangle. Now here, if hypotenuse is equal to 17 unit, then the base will be 8 unit. But here we don't have the value of perpendicular with us. But again, we can easily find it with the help of Pythagoras theorem. And remember, as per the Pythagoras theorem, the square of hypotenuse is equal to the sum of squares of perpendicular and the base. And that means perpendicular is equal to the square root of difference of squares of hypotenuse and the base. So here hypotenuse is equal to the square root of 17 square minus 8 square, which is equal to the square root of 289 minus 64, which is equal to the square root of 225, which is equal to 15. So that means here perpendicular is equal to 15. So now what will be the value of sine theta? The sine theta is equal to perpendicular upon hypotenuse, which in this case is equal to 15 upon 17. That means sine theta is equal to 15 upon 17. So that means theta is equal to sine inverse 15 upon 17. And also theta is also equal to sec inverse 17 upon 8. So that means sec inverse 17 upon 8 is equal to sine inverse 15 upon 17. So that means in place of sec inverse 17 upon 8, we can write sine inverse 15 upon 17. So the expression sine of sec inverse 17 upon 8 now becomes sine of sine inverse 15 upon 17. And remember, sine of sine inverse x is equal to x. So that means sine of sine inverse 15 upon 17 is equal to 15 upon 17. And that means sine of sec inverse 17 upon 8 is equal to 15 upon 17.